Hey, I'm Eric George with the Building Performance Group. We do energy efficiency consulting in Indiana and Kentucky. We're here at a new construction house today. It's going to be certified for the Energy Star Homes program, and we're going to do a walkthrough with what's called the thermal bypass check, which is basically a pre-drywall inspection to look for insulation, air sealing, and duct sealing problems. So come on inside and follow me while we go through the house and point out some problems and some good things that the house has before it gets Energy Star certified. First thing we're going to look at is the garage. If there's any living space above the garage, commonly referred to as a bonus room, the insulation actually needs to be in full contact with the floor above it. And you can see there's some spots here where the insulation is towards the bottom of the cavities, and some of them where it's actually up against the floor like that. So all this insulation needs to get pushed up against the floor and supported with wire ties or some other kind of support that's going to keep it in contact with the floor. In addition to that, if there's any space above the garage, like right here, that's not living space, each one of these cavities needs to be blocked with foam board or another solid material and sealed to the surrounding framing so that you don't get air movement between the floor. Let's go on inside the house and see what else we can find. So now walking through the inside of the house, we're going to look for any penetration that goes from a conditioned space of the house to an unconditioned space. And we found several right here along what's called the rim joist. So on this side of the house right here, we're in a bathroom of the master bedroom. And on this side, above the ceiling, is attic space. So these pipes that penetrate through the rim joist go from a conditioned space to an unconditioned attic, and therefore they need to be sealed with caulk or foam, something that's going to stop air movement. Each one of them. So the other thing we're looking for is really good air sealing. We want to make sure that the bottom plates and the exterior walls have been either foamed or caulked with a latex caulk or a silicone caulk. The base plates or bottom plates of the home can actually leak up to 27% of all the air in the house, depending on the style of the house. So it's really important that the bottom plates, as well as the outside corners, get caulked or foamed. You also want to caulk or foam the top plates around all the exterior walls. And this house did a really good job of doing that. So another common occurrence in homes that you're going to find is a lot of, especially custom homes, are walls that face attic space like this wall. This wall here, it's a full height wall, but there's no wood backing on it facing the attic space. So literally what they've done is put house wrap up there and secured it to the top plate and the bottom plate of that wall, and then insulated the back side of it. So that's a good example of an air barrier on a knee wall. And this right here is another example of an air barrier on a knee wall. This wall actually extends up another probably 8 to 10 feet, and you can't see the back of the knee wall, but we know it does because it does on that side right there. So all the way across here, again, they've run house wrap so that you have an air barrier to prevent attic air from circulating through the fiberglass and diminishing the R value of the insulation. So we found one section of the house that's actually missing insulation along the rim joist, and it's where you have a drop ceiling right here in the dining room. And so each one of these little bays needs to get insulated with fiberglass before they drywall. So they're going to go through and do that before these guys get to hanging the board. So anytime you've got a vaulted ceiling in a house, you have a potential problem, especially if it's going to be insulated with fiberglass bats. The fiberglass that you see here needs to be in direct contact with the drywall so that the thermal boundary is touching the pressure boundary as it's supposed to. Across the top of this ridge, they've got a little bit of a collar where they've only got a 2x4 going across there, so if they try to insulate that, all you're going to have is basically an R13 across the top of the wall, or top of the ceiling. So I suggest that the builder fur this down with a 2x6 so that they can get a full R30 going straight across the top of that ceiling, and then bring the insulation down a little bit so you don't have these little pockets around the framing. And just fill it in a little bit better. This wall here, again, is another example of a knee wall. And if you go around to the side here, you can actually see that that knee wall is exposed to the outside over the front porch overhang. And you can literally see the fiberglass has no cover on the back side of it. So we need to put Tyvek up there or foam board or some kind of air barrier, and also wrap it across the top of that wall. So all 6 sides of those insulation cavities are encompassed with an air barrier. So another common problem that you're going to find in homes is a platform that's built up in an attic for the furnace to sit on top of. In this house, they've actually built up the platform a little bit by using a couple of 2x4s, but really it needs to be another 2x6 or a 2x8 to give you the full amount of insulation underneath the furnace, or else it's just going to be a colder spot in the house. In addition to this little area here, you can also see that the ductwork that's up in the attic has been sealed with duct mastic. And duct mastic is basically the gray, putty-like material that goes around the collar and ties the collar to the junction box. You want to use duct mastic or a UL rated metal tape at high pressure zones in the duct system, so around the plenum, especially the takeoffs and the collars, and also where the flex duct or the metal duct connects to the boots. So make sure that you seal the duct system really well. You can only have 6 CFM per 100 square foot of conditioned space of duct leakage in current version 2 Energy Star standards. So we found another spot in the house that's going to be need to be addressed before the house is finished. Anytime you've got knee walls, you can be sure that you're probably going to find knee wall attic accesses. So this is, roughly a 2x2 or 3x3 attic access that needs to be insulated. It's part of the outside wall. It's an exterior wall. So what I recommend you do is take 2-inch thick foam board and either glue it or mechanically fasten it to the back side of the drywall that's going to go there, and then also weather strip the opening so that it's nice and tight. It's going to be air sealed well, and you're not going to have a cold spot in the wall. And we also have another one right here. Same issue, same thing needs to happen. Just make sure it gets weather stripped and 2-inch foam board put on the back. You can also use fiberglass in the back side, but I recommend using the fiberglass that's encased in plastic or has some kind of an air barrier on the back side of it. Otherwise, it's really not going to do its purpose. Just like the rest of the knee walls need to have an air barrier, so does the attic access as well. So we're also going to take note when we do an Energy Star home certification. During the thermal bypass inspection, we take note of the type of insulation that's installed as well as the quality of the insulation itself. The insulation is graded on a scale of 1 to 3, with 1 being the absolute best, which typically is a full-blown cellulose or spray foam or fiberglass insulation, and grade 3 is the worst, which would be typically fiberglass insulation like this. Rolled fiberglass is just really difficult to install perfectly as the manufacturer intends, so what ends up happening is you usually get compression around electrical boxes and where you have electrical lines and stuff like that. So when the insulation gets compressed, it loses its R value, and so typically, 99 times out of 100, you're going to call fiberglass batt insulation a grade 3 insulation when you're rating a house. Spray foam, cellulose, blown fiberglass will be a grade 1. So it's one step in the Energy Star home certification process.